I am the principal engineer at Aerospike. We have a horizontally scalable NoSQL database, but that's not really the topic of tonight. The topic of tonight is instant ad response via real-time transactional analysis, which is a mouthful. So let me first explain. This talk is really going to be about, we have some market leaders in online advertising, and online advertising represents one of the most challenging parallels in big data. Online advertising, you need ultra low latency responses, but the requests for these responses are actually very complicated aggregations and analysis of data. So these represent some of the hardest big data problems today. And basically, I'm just going to pick these guys' brains, and they're going to tell us all the stories of the data stores they use, and the how and the why, and how they handle big data, and how they get real-time responses that get you, your perfect ad that you're going to click through on that makes this whole industry run. So here are the people we have. Can you guys tell me a little bit about yourself? Starting with Andre.
I'm Andre Dunca. I'm the co-founder and CTO of LiveRail. LiveRail is an online advertising technology company. We focus exclusively on video advertising. We provide technology solutions for the entire video advertising industry, from the sell side to the buy side. We service publishers, vertical networks, ad networks, trading desks, DSPs, and even agencies.
My name is Mike Yudin. I'm CTO of AdMarketplace. AdMarketplace does what's called search syndication. How many of you guys know what that is? Not so many. So you probably have heard at sessions here that it's all about display marketing mostly, and the gold standard that everybody's trying to get to and can't quite get to is search, right? Google, search, AdWords, that's the gold standard, and nobody talks about this, right? Why? Because Google figured it out. So what's there to talk about? It's been figured out. So it turns out not quite. Comscore just published a study that 40% of all searches online happen outside of search engines. So you may not even realize this, but Google kind of conditioned all of us to use search boxes. And search boxes are all over the place. You go to Amazon, what do? You search. You misspell a URL and you get to a park domain, it's going to be a search box. There's toolbars in our browsers, and we search in these toolbars. So there's all these different searches that happen. And the search is the best way to express user intent. So what our company does is aggregates all this non-major search engine search traffic, right? From all these disparate traffic sources. There's lots of them. And so it's a very difficult and big data problem. That's why I'm here. Right? We like to talk about this in 3 dimensions of targeting. So you've got the user, that's dimension 1. And so this user is coming to you from a certain traffic source, that's 2, right? And the keyword itself, or the search term, that's 3. So that's a very, very big data problem. And it's hard technologically. So most of the talks here have been kind of high level. Hey, we match the user with all this audience demographics data. I'm sure Alex will talk more about this, but we're here to talk about how the rubber actually hits the road. How this all happens so that when you see a web page and there's an ad on this page, it shows up instantaneously, right, and correctly. So that's a serious problem.
Great. So I'm Alex Hooshmand. I'm one of the co-founders of BlueKai. I head product and operations at BlueKai. BlueKai, probably the best way to understand what we do is to give you a sense of our history. We started out as the first and now largest online data exchange. What that means is we go to websites where useful behavior by users is occurring, where we capture information about what users are doing. We get that data out to places where that data can be used for ad targeting. And this is sort of the data exchange part of our business. About 2 years ago, we also started looking at providing a platform for advertisers and publishers to capture, organize, and also get their data out to places where ads could be targeted. Most recently, we've been expanding not only to getting data out to places where ads are targeted, but also getting data to wherever it could be used. So e-commerce systems, site optimization, video, trafficking and targeting systems. So think of us as a data activation system, a data management platform, and on both fronts, I think we're probably the largest out there. Just by way of background, I started out in the business at DoubleClick. I don't know if there are any current or ex-DoubleClick people out here. And also, after that, I was at Right Media and Yahoo. So I'd love to catch up with anyone from those companies.
Okay, this should go without saying, but this is a relatively informal panel, so if you guys have questions, just raise your hands and we'll call on you, and please ask questions. And if we're getting too technical, say too technical. If it's not technical enough, just kind of holler it out if you want. We're trying to get you guys interested in this stuff, so just feel free to ask questions or give advice. Let me dive into the questions of big data so people know what we're talking about here. Online advertising is very big data. So my first question is basically, people talk about big data in three, they call them four V's. They say volume, variety, velocity, and value. Anyways, I don't want to explain to you what those are, but let me, because that's just a long conversation. Let me ask you guys, in online advertising, how do you guys define big data? Is it speed? Is it massive amounts of petabytes of data that lie around that you rarely analyze? Is it a combination of the two? Is it massive throughput? If anyone can jump in, what's big data for online advertising for your companies?
Sure. I can take a crack. So actually we have different combinations of all four of those sort of dimensions if you think about it. In what we do, which is capturing data and then getting it out in real time to places where ads are targeted, if you think about those vectors, there are certain problems that we solve that are in the milliseconds or sub-milliseconds time frames. It has to do with in real time a call come to us and we look at a user's profile, basically respond, actually using your technology as a foundation for what we do, respond with information about a user. So that was one class of problem. We do that about 1 trillion times a month, and last month we actually hit run rates of about 2 trillion times a month. And so all of that information has to get captured because we're also the platform that accounts for what's happening with this data. We have to understand whether the source of the data is, where it's going. In some cases, we have to charge people for it. So there's a class of problems around taking that data and aggregating it in a way that can then show up in our reporting. And there, the big problem is just a sheer volume of data that you have to deal with. And there we deal with a combination of house or sort of surf world technologies and also open source technologies that are out there. The third version is around analytics, and again, we have two sub-flavors there now to get really detailed. There's a class of analytics that we do that's where the results have to come back in seconds. Things like, I have 100,000 categories of data in my taxonomy as an advertiser. That's unusual. The largest we see is about 20,000, but overall we have 100,000. I want to be able to combine that in any kind of a Boolean expression. So a bunch of things or together or ended together, or and ended together. And I want you to come back in a couple of seconds with how many users are in that at the intersection of that Boolean expression. That kind of an analytics problem requires a very specific type of solution. And then sort of the fourth class is analytics problems that requires to hand in the query and come back in a day and get a response. And typically in online advertising, those are the results that are tied to conversions or clicks because there are not that many of them. And so, for example, sampling doesn't work. Frankly, we deal with all four classes. There may be others, but I haven't come across any. Okay.
Well, to add to this, I define it very simply. It's more data that can fit into servers, RAM, memory, if you're talking about real-time ad response, or it's more data than traditional databases can handle. The type of data we're dealing with, you can't use Oracle for this. It's more data than big banks deal with, and querying should happen very fast. So nobody's going to wait 3 days to get results in response for one question, and this data is just exploding. It's more and more and more of it. So it's about scaling. Today my company processes 1 billion requests for ads a day, and I know that by the end of the year it's going to be 3 billion. And so whatever we build, I can't afford to throw it out. It has to scale to this. So that's a challenge.
Yeah, I think we at LiveRail see pretty much the same flavors. I think there are two polar opposites in big data. One of them is real-time, fast responses, 1 millisecond, under 1 millisecond. And the other one is the data warehousing problem. The data warehousing problem has been around for a long time now, but the real-time big data is somewhat new, especially with companies and services like BlueKai, and also with the emergence of real-time bidding. Companies such as LiveRail use real-time data to be able to interact with other real-time bidding ecosystems and do things like cookie syncing and other metadata syncing, which is another very, very largely used use case for real-time big data.
Okay, I want to raise a point here, and that's one of the most interesting parts in real-time advertising is the part of the data that's served in real time and the part that's analytics and how they're combined. And so this speaks more to the V value, which is to say current data is very important, whereas historical data is important but not quite as important, or it's important only as an aggregation. And in online advertising, this is a big deal because people want to know things that are trending, but they also want to know if this person has a history of shopping at a certain store. So I wanted to dive a little bit deeper into the value part and ask you guys, what data do you store in the real time? What do you need to serve back quickly for the ads that we all see? And then what parts are more done on the day running job, the day long running jobs, and how do you combine the two? That's always been kind of like a mystery to me because they're fundamentally different things. One's a quick lookup and the other one is a long running process, and they just have nothing in common with each other. So if you guys could talk about that, because it's one of the hardest technical challenges in online advertising.
Well, I think the purpose of the data matters a lot. When you're about to make an ad decision, you need data fast, and when you want to report, you need some other kind of data. So I think those are the two different vectors of this problem: decisioning versus reporting.
Right.
Yeah. Go ahead.
Okay, so the way we approach this is we keep in the real-time kind of cache, which is powered by Aerospike, coincidentally, 30 days of users' history. So we did our entire business is based on tracking performance of ads. So we've done analysis, and pretty much any kind of intent expressed past 30 days, we concluded it's not very useful. So even if it's a longer-term purchasing decision, such as buying a cruise or even a house, in 30 days you've likely have come to a conclusion of this. So we keep 30 days in real time. And so what happens inside the ad server is we get a request for an ad from a user. We look up in this real-time store. We combine this with data that we have pre-computed. So if there's one advice I can give you how to do things at scale is make your real-time system as simple as possible. So you can run really complex algorithms offline and just feed them into your real-time system. And you gotta have a feedback loop, right? So whatever you pulled out of the real-time data store, whatever your algorithm decided based on pre-computed, pre-hashed data, you serve these ads and you output what just happened into log files essentially. And then you have a asynchronous system of pulling these log files, processing them. You can afford to do it within an hour typically, and then feed this into your data warehouse, and then use for your analytical algorithms. So that's how we combine kind of the two together.
Yeah, if I can add to that, I mean, we do we have a very similar setup, but if I translate that into product speak as a product manager, if you think about the things you can do with data and advertising, you have retargeting as a tactic, you've got prospecting, which is using third-party data, and there's using lookalike models and lookalike modeling and data based on lookalike modeling. The first two sort of fall into that, don't process too much, very real time, just get it into the profile store and get it out fast. The faster you can use that kind of data, the better. So with retargeting data, if someone came to your site and browsed, you want to hit them immediately with ads as they get off site, and the faster the better. Frankly, similar, prospecting is similar, especially prospecting based on search data. The faster you hit them, the better. And the key there is the quality of the underlying data there. You don't want to be doing a lot of processing. When someone's on your site, that's enough of a powerful signal that any kind of model you try to build on top of that, frankly, is in my opinion, at least, a waste of time. Same with sort of search-based prospecting data. It's really the third class, which is lookalikes, that requires this additional layer you were talking about, which is get it offline, do some analysis, and probably run some sort of an extraction job to get the information, the IDs out, the user IDs. That's, by the way, how you do it. You tie everything back to a universal user ID. And then get it back into the profile store. In those instances, you're building models that typically are much more holistic. They take intent data into consideration, demographic, psychographic, and just a whole different class of data or sets of data that we would in retargeting and prospecting.
Okay.
I hope that gives you a sense.
No, it's good. It's very good. This is a 15-minute mark. Does anyone have any questions? You don't have to. Are we going? Yeah, please.
So, what data warehouse are you using for your analytical processing? And I guess all of you are using Aerospike. So that you mentioned, I think, 2 trillion requests per hour per day.
Per month.
Per month. Yeah. Yeah, it's like what?
Whoa.
I was like trying to do the math. Like that's a. Yeah. So how big is the cluster that serves that? So how does that infrastructure look like, and for each of you?
Sure. So again, part of your question already contains an answer, right? So this requires a data warehouse, which is not used at real-time ad serving, but it's used to store historic data. So the answer to your question is it's a company called Vertica, which is what's called an MPP database, and there are several of them. Green Plum and Parexel is a new one, and Teradata, and we evaluated all of them. So we concluded that this is what we're going to do, and so far it works. It's we do not use a Hadoop cluster, and so that's a scalable, clustered data warehouse, and you can load data into this type of database, at a very good rate, and it's compresses it, so you don't have to use Hadoop.
So for the, we use, when we started out, which was around 2007, that feels like eons ago, which sounds crazy, but it does feel that way. A lot of this stuff didn't exist, and so we have a lot of in-house code. But over time, we're actually replaced it with best-of-breed components from solutions in the market or in the open source community. For the very real-time stuff, profile store, real-time responses, obviously Aerospike. For log aggregation, we use Netezza. And then for the analytics piece, we have 2 different Hadoop clusters. The sort of inventory systems that do the Boolean sort of querying and real-time, few seconds response is a cluster of, I think, 12 computers or 12 servers, and then the audience analytics that we run, which is the types of problems similar to, hey, I just ran a campaign. This campaign had 1,000, or actually 1,000 sometimes is a lot, a few hundred conversions. Tell me which categories of users are disproportionately present in these converters, That's about 20 servers, I think. The first one is sampled, the second one is unsampled, and that sort of drives the difference.
You have a total of 32 servers in your infrastructure?
I think it's more. Well, no, on the Pixel server front it's 300.
Okay.
On the analytics front, it's more than what I mentioned. I don't know what the other servers are used for.
But your total aggregate server count is under 500?
Yes.
Interesting.
Well, they're powerful servers these days.
Yeah.
So
This was a great question because it was my next question.
So let's make this super interactive. Why was that interesting for you?
Well, because people have thrown out a lot of really large server counts. I mean, Google for the spanner has millions of servers deployed worldwide.
Yeah.
And so when you hear the amount of requests you're talking about, that implies a very large number of requests per CPU. And that's, I/O is mostly the bottleneck now. But I'm curious how many requests you're doing per CPU. I was kind of trying to run the math in my head.
Yeah. I don't have it off the top of my head. I can tell you, for example, we have something like 2.5 to 3 billion log lines generated a day.
Yeah.
So 60 billion, 90 billion a month, I guess, to just compare it to the number of data points.
Well, that's a separate problem even in of itself. Parsing the logs. My God.
Yeah. To go back, and this brings up a really important issue, which is one of your 4 variables is value, which I think of it as cost in my world. And cost is a really important thing. Believe it or not, even with all the cheap technologies now, quote unquote cheap technologies that are out there, we're still in the advertising space hitting the limits of what can be done in a cost-effective way. So when we started out, we didn't really go and build the business models to figure out, hey, can we actually do this and make money at it? We kind of just did it and hoped for the best. We kind of knew we could at the volumes we're dealing with. Now we're getting to the point where anything we decide to build, we actually have to run the models to understand, is it going to be profitable or not? Because the volumes are just so much higher.
So as I understand real-time bidding, the process essentially, user goes to a website, and then there's a back-end process that is sort of a bidding war that happens, within about 100 milliseconds.
Yeah.
Is there a limit to the number of participating bidders that you can have in those sort of auctions, and how is it limited? Because I imagine that if the query database for how many people you're querying to figure out whether, yes, they have these cookies or they want to hit the people with these cookies, if that database is too large, certainly the request is going to take a lot of time. So is there a limit on the number of participants?
So, first of all, if you guys want to take any of this, I'm happy to
Yeah.
Because the thing is, we deliver data to the bidders. We actually don't have a bidder ourselves. So I have an indirect view of what's going on. I can tell you, but maybe you guys know better.
Yeah, there usually isn't a limit because learn that you don't have tens of thousands of participating buyers. And yes, the calls should be under 100 milliseconds in round trip.
Back in my Right Media days, when Right Media holistically conducted the auction, but everyone had to be in the Right Media system. It wasn't really RTB, but still it was an auction. There were limits to how many participants there could be, but it was still in the. You really don't think of it as advertisers. You think of it as number of campaigns that are
Right.
that are. It was in the thousands that could, but beyond that, it wasn't scaling. I don't know if that's still the case today or not.
well, Right Media had some technical limitations for this, but
Yeah.
So we do about 100 requests per second per core. The typical server is 16 cores, so you can figure that out. And
Is there any impetus to grow that number? I mean, is that where your bottleneck is? I'm curious.
the bottleneck is in CPU actually. So, but that it's a good problem, right? That's the best kind of bottleneck.
Right.
So,
Yeah, amazingly, actually, it's the same for us. It's just weird.
That's interesting because a lot of the database systems have an I/O bottleneck. To what do you attribute the CPU bottleneck as opposed to the I/O?
well, so
Sorry.
What type of request? I want to say because there's a big
Yeah.
difference. Are we talking analytics, or are we talking
no,
real-time?
real time. So I think this can partially be attributed to SSD, solid state drives. So some of the data is stored on solid state drives in Aerospike, and so that allows for very, very fast response time if your read to write ratio is right. And some of the data is cached in memory. So you can't really do much I/O anyway. So you have to design your systems in such a way that you don't. And if you do, you just read some data off SSDs.
Yeah, Andre said if you're trying to be fast, keep it simple, and we tried, but we kind of failed a little bit. So we run some logic in the real-time systems, and that's what slows the CPU down.
And in online advertising, how important is speed and scale? How important is speed and scale and latency? How much of a competitive advantage does that?
Oh, it's everything. You can think of this as an auction, right? Where whoever wins puts up the pedal first wins. It's very often the case. You can be bidding more than the other guy, but if you're late to the auction, nobody is going to take your bid. So it's extremely important. There's probably nothing more important than this.
In that case, could you contrast this with financial networks and sort of the requirements there? Because obviously when you're bidding on stock, it's the hyper-speed trading is all who can get in within the millisecond.
Right. Well, for those guys, it's microseconds.
Right.
So,
Right.
We're lucky. But they have to buy, much more expensive specialized hardware to do
So
this.
it's much slower than the high-speed
Yes,
trading
yeah.
transactions.
If I can return an ad in 5 milliseconds, I'm good.
But the amount of data is much bigger.
Right.
That's true. That's
So
true.
it's a different one. They do ultra low latency, but it's not a lot of data. Financial data
Right.
is not half as big as what these guys are
Right.
doing.
Interesting.
So your data warehouses, are they actually closer to the exchanges? Like, do you actually factor that in? Are you actually have to be that fast that your servers are actually like next door to like AppNexus or something?
Not 100% next door, but speed of light matters actually in our world, believe it or not.
Yeah.
So
But how much?
we can't work out of one data center. We need probably 3 data centers in the U.S. Let's put it that way. So it matters, but it doesn't matter as much as.
You get 30 milliseconds between California and New York, so it's not that bad.
Yeah. Every little bit helps,
That's
right?
That's pretty bad.
Well,
30
yeah.
milliseconds is pretty bad. Yeah. So I think you need presence on both East Coast and West Coast, and in some cases Texas as well, to
But
have
there's no
very
need
low
to have like
latency.
40 or 50 nodes in the U.S.
Sorry.
There's no need to have like 40 or 50 nodes geographically dispersed like a content delivery network now.
No. Well, some of the content is on content delivery networks, but you can't really put any kind of decision logic there.
Right.
So, but you don't have to. If you strategically locate your data centers, at places where lots of backbone providers meet, you're gonna be fine. It's 2 or 3.
On that same subject, do you guys leverage CDNs at all in any of your businesses?
Yes.
Yep.
Yes.
So only for static content?
DNS also matters, right? So you got to be smart about how you do DNS, and there's some advanced tricks that can be done with it.
Is this too technical? Not technical enough? Because I'm an engineer. I'll geek out on this stuff all day. Can I get it?
Actually, more very basic question.
Hey, can we ask, going forward, can you just introduce yourself quickly? Which
Yeah,
company?
sure. So I work for Compass Labs, product manager. We do social apps.
Okay.
So I wanted to understand the process of RTB, right? So let's say that I visit CNN.com and an impression, and that impression, and what data is given out to RTBs and what exactly is going on?
Yeah. You want me?
So because the calls happen in the background server side, those other bidders need information about the environment and about the user. Information about the environment is stuff like user agent, so browser information. Obviously the location of the user. And then the information about the user itself is achieved through syncing cookies. So the initial point of contact and the bidder need a way to cookie sync in such a way that the initial point of contact will either send the bidder's cookie ID for that user or their own cookie ID for that user, but then the bidder needs to hold the cookie map. So that's how you send information about the user. So those two are the most important, I'd say.
You're saying the bidder won't be able to know much about the user unless he has all of that mapping.
Exactly.
Yeah, if you think about it, all these systems are constantly ID syncing with each other. So the bidder is ID syncing with the source of the ad inventory, the exchanges usually, or sell-side platforms. and then the bidder is also ID syncing with us. The data is passed via the exchange is really contextual data and user agents and things like that. The data that's user data is usually passed by us via our ID sync with them, as an example. And that's, yes, user-based information. But literally there's, at any given time, probably hundreds of ID syncs going on in the ecosystem.
So it's pretty crazy. I read some stats somewhere that 10% of all power consumption in New York City metro area where I'm from is by data centers.
Yeah.
And that's what they do. They just ship this, terabytes of data back and forth, so you can see a better ad.
All right. Okay, you guys talked about your stacks. This is me. This is my personal geek question. You talked about numerous databases, maybe 4 or 5, 6 databases. And what I want to know is, when I hear that as an architect, I think gluing them together is possibly more work than using the databases, or it's a nightmare, or it's a good thing. How much time, how much effort do you spend gluing these different technologies together? Is it a major infrastructure cost?
It's difficult. It actually sucks because these key value stores, and you can't really query them across all the data that's stored inside them. And even if you do, that's probably going to slow down your real-time ad response, and you have your traditional SQL databases. So we have to do some hacks, and if these guys can help us figure it out, that would be great.
Yeah.
Yeah, I would say that's the hardest part, and there's actually a people cost involved to that, because a lot of that stuff is you need an analytics coding team that custom writes that stuff, and it's actually not their favorite kind of work. A lot of the guys want to be doing data science and analytics and building models, and this sort of connection of systems is, how should I put it, it's an evil they put up with. Yeah, it's a very important problem, and it's one of the harder problems out there, I think.
For sure.
All right, just to change this.
You know any good analytics people? I'm just kidding.
Yeah, later. We'll do it later. Yeah, I think.
Yeah.
Let me switch this up a little. Your guys, your infrastructure. Is it virtual? Is it EC2? Is it bare metal? What are your opinions on that? Because you guys have basically extreme data cases in different. You have extreme analytics. You have extreme real time. So what are your kind of personal, philosophical, religious beliefs on the virtualization of these tools? Virtualization meaning your own virtual systems, or EC2, or bare metal. There's kind of 3 different ones. If you guys just want to talk about that, because to virtualize data stores is one of the harder virtualizations.
Sure.
It's not like an app server. It's very easy.
Yeah.
So.
Well, my least favorite word here is cloud, because what is cloud? It's a virtualized data center, essentially. So we do virtualize some stuff, but only basically peripheral and secondary systems, and development and testing systems. We own all the infrastructure. We're talking about these types of SLAs and response. You have to own the whole stack. From your firewall to your router to your bare metal server. That's been my philosophy.
We use a mix of cloud and dedicated hardware. We use EC2 for the cloud. The primary reason is that it's really easy to use and scale rapidly, especially in an industry that's not very mature and spikes happen very often. We need to be able to react very quickly to that. And another reason for choosing EC2 is their global presence. We are able to deliver ads faster to Europe, Asia Pacific. We could do it in South America as well if there was a need for that. So I think their global presence is a big plus. And then for mission critical systems that cannot go down, we use people like Rackspace, dedicated hardware and very well managed hardware.
Yeah, interestingly, we started out very much like you, and we're now more like you. And the turning point for us was we hired a bunch of Amazon people. And those guys, if you talk about religious, those guys are fanatics when it comes to that stuff. So they somehow, I think they literally called up Amazon and said, you have to lower your prices so we can put stuff on your server. And so anyway, at that point, we made the transition to a mixed environment. I think the prices are getting to the point where you can actually do a lot more in something like EC2 than you even could maybe 3 years ago, I'd say.
Okay.
Yeah. No, it's a viable extension to infrastructure for sure. Also, the price of getting data in and out of EC2 is prohibitive. So, that's one of issues, we've repeatedly brought up with them. But it's getting better for sure.
So you guys talk about scaling a lot and the sort of on-demand nature.
Who's moderating the panel?
Yeah, I know, right? I'm in your head. So we deal a lot with distributed databases, and we've looked at using machine
Who's
learning.
we, by the way?
Sorry. I work for a company called 2600 Hertz. We deal with telephony infrastructure.
Okay.
So we've looked at using machine learning because we deploy nodes on demand based on the volume of use. Have you guys, what are the metrics that you use to determine when you add new servers to the cluster? And have you looked at doing any automation around this?
Okay, well, it's a technical question again, right?
Yeah. Sorry.
So yeah, we do use automation. We use tools like Puppet,
Yeah.
and we have capacity projections. It's a pretty boring question, and that's one of the downsides of having owned infrastructure is you have to have some spare capacity.
Right.
So, yeah.
But let's talk more about scale. You guys started small, you grew big, so there's a lot of scales we have to talk about. There's of course I want to say about data scalability, but there's also you have all these different technologies. You have to scale people. People cost money. What, as you grew, was the biggest challenge? Was it the software? Was it hiring people for the software? Was it the hardware? Was it the infrastructure?
Managing egos.
That we can solve, that we can talk about.
And that's at every level. There's just biggest egos are in the sales and BD groups. So let's start with that. And then if you can do that, then engineering and product I think are okay. Look, you're dealing with a bunch of really, really smart people. And you need to do two things. You need to, one, make sure they understand that the company is either successful right now or is going to be successful. And we started out in the Valley, and it's a pretty hot market here, and it's been a hot market. I don't care. There was no recession here, in my opinion, especially in this space. And so there's that aspect to it. And then there's also the people have to believe in the other people that they work with. So you just have to make sure that you manage hiring and manage your team in such a way that when people join, they actually feel inspired by the people around them. And that's a really tough challenge, partially because it's easy to have false positives in your hiring process. And then if you do have that, you have to ease people out, and that's a very hard thing. So I can't believe I'm saying this, but as a technology company, my biggest problem is a people problem.
Oh, there's no question about it. If we didn't have to deal with people, everything would be easy. So, yeah, and it's a different challenge depending on what stage you're at. If you have 7 employees and everybody is a critical contributor. And I read a blog post by Fred Wilson today, I believe, and he said that it's better to have a hole than an asshole. So I think that's very true. It's very true. And then as you grow bigger, the challenge becomes actually to keep your company culture, right? Because the initial people are very passionate, they know why they're there. And then some people get hired into an already successful organization, and they sort of don't care. And you want to avoid having that type of degradation in your company culture, right?
Yeah, I mean, I can confirm that people is tough. Scaling teams, making sure that as a team scales, it has its own optimal hierarchy and management, and things get done right in this team, and this team is growing properly.
And there's a particularly tricky point right around when you hit 100 people as a company, probably have something like 30 to 50 engineers, and just in every department, you need to create some structure, some sort of management layers and middle management layers, but yet you're not big enough where everyone can have their own empire. And I'm putting this a little bit more negatively than it is, just for the sake of being dramatic about it. But and you just have to be able to manage that. That's a very, very tough transition point, I think, right around 100 for a company. It's also the point, if you read this book called, I think it's called Peopleware, and I think there's a point at Microsoft where every Microsoft employee had to read that when they started. Right around 100 is when you stop knowing everyone else in the company. Sub 100, everyone tends to have some sense of everyone else and what they do. And so your communication systems kind of have to change, and processes have to change, and that itself is also very tricky. I feel bad again talking about tech stuff.
No, it's all right. I asked the generic scaling question, now I asked the tech scaling question.
Sure.
You guys have complicated platforms. What's the hardest part to scale of your platforms? Where have you had the biggest nightmares, and how'd you deal with them?
I think from our point of view, the biggest challenge is still our data pipeline, because we have to connect all these systems together and make sure that that's optimal. So that's, in my point of view, that's the part I'm still not happy about. And we're continuously trying to improve it, make the ETL run faster, and aggregate the data faster and transfer the data faster from one place to another.
100%.
Yeah, I would agree with this. Data, data infrastructure is probably just the basic plumbing of, reporting and analytical dashboards, and this is sort of the last thing you always build, right? Because the first thing you build is your bread and butter stuff, and it's usually pretty good, or you're gonna go out of business. But then, your customers demand more and more, powerful, fast, and cool tools, and it's expensive to build those tools at scale.
I would say there's one additional element for us, because we're mostly dealing with enterprise level clients, and it's their most important data, their customer data, their website data. And so for us now, more and more security has become a challenge, and security related infrastructure or questions have become a challenge. So I would just add that to what you said.
Yeah.
I think we're out of time. Is that they're clapping? Does that mean, or do we keep going? Do I have to end, or can we keep going? We're just gonna keep going. All right. Let me think. You guys make user profiles, right? It's a huge part of your business, right? How much of an advantage is it to have, or how much does it change your business to have incredibly deep insight into each and every user? And then can you guys just talk about how deep you go into each user, how much you track, how much the technology helps? It's a generic question, but can you guys work with that one?
Sure. Yeah, I think right before you came to this panel, you searched for dog food, and you're looking for tickets to LA. So yeah, I would say I would go pretty deep.
Yeah, I'm pretty much out of questions. Do you guys have any questions? Does anyone have any questions? If you do, you can ask them now in front of everybody, or just come up individually afterwards. And that's it.
Thank you.
Thank you.